There are no size limitations on a closed closet that would prevent the installation of overcurrent protection within it. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can lead to overheating and fire hazards. The National Electrical Code, or NEC, sets the standards for safe electrical installations. The NEC addresses the placement of overcurrent protection in various locations, including closed closets, to ensure safety. While there are no specific size restrictions on closets concerning overcurrent protection placement, there are other crucial considerations to keep in mind. Firstly, the working clearances around electrical equipment must be maintained. The NEC mandates specific clearances to provide sufficient space for safe operation and maintenance of electrical equipment. These clearances ensure that electricians can access and work on the equipment without risk of electrical shock or injury. The required clearances vary depending on the voltage of the equipment and the layout of the surrounding area. Secondly, the NEC addresses the issue of dedicated equipment space. This refers to the area directly above and below electrical equipment that must be kept clear of obstructions. The purpose of dedicated equipment space is to provide unobstructed access to the equipment for maintenance and repairs. It also helps to prevent damage to the equipment from accidental contact or impact. Thirdly, the NEC specifies the types of equipment that are permitted in closed closets. Generally, only equipment that is directly related to the closet's function, such as lighting and ventilation, is allowed. Other electrical equipment, such as receptacles and appliances, may be prohibited. Fourthly, the NEC regulates the installation of luminaires, or light fixtures, in closed closets to prevent fire hazards. The code specifies minimum clearances between luminaires and storage areas to ensure that combustible materials do not come into contact with hot light bulbs. The type of luminaire allowed depends on its design and heat output. Fifthly, the NEC requires that all electrical installations comply with the manufacturer's instructions. This includes following the specified wiring methods, grounding requirements, and installation procedures. Compliance with manufacturer's instructions is essential to ensure the safe and reliable operation of electrical equipment. Sixthly, it's essential to ensure adequate ventilation around electrical equipment. Overcurrent protection devices generate heat during operation, and proper ventilation helps to dissipate this heat and prevent overheating. Insufficient ventilation can lead to premature failure of the equipment and increase the risk of fire. Seventhly, all electrical work must be performed by qualified and licensed electricians. They have the training and experience necessary to ensure that installations comply with all applicable codes and standards. Attempting to perform electrical work without proper qualifications can be dangerous and may result in serious injury or property damage. Eighthly, regular inspections and maintenance of electrical systems are essential to ensure their continued safety and reliability. Overcurrent protection devices should be tested periodically to verify that they are functioning properly. Wiring and connections should be inspected for signs of damage or deterioration. Ninthly, consider the ambient temperature within the closet. High temperatures can affect the performance of overcurrent protection devices, potentially causing them to trip prematurely or fail to trip when needed. Tenthly, while the closet size itself doesn't restrict overcurrent protection installation, the available wall space for mounting the equipment is a practical consideration. Ensure there is enough unobstructed space to safely install and access the panel or device. Keep in mind that local amendments to the NEC may exist. Always consult with local authorities having jurisdiction, or ODGs, to ensure compliance with local electrical codes and regulations. These local codes may have additional requirements or restrictions regarding the installation of electrical equipment in closed closets. For example, some jurisdictions may require the use of arc fault circuit interrupters, or RFCs, in closets to provide enhanced protection against electrical fires. Others may have specific requirements for the type of wiring used in closets or the placement of receptacles. Overcurrent protection devices are essential components of any electrical system, protecting against overloads and short circuits. Circuit breakers and fuses are two common types of overcurrent protection devices. Circuit breakers are resettable devices that trip when the current exceeds a predetermined level. Fuses are one-time devices that melt and break the circuit when the current exceeds their rating. Both circuit breakers and fuses must be properly sized to protect the circuit from damage. To determine the appropriate size of overcurrent protection, consider the ampacity of the conductors in the circuit. The ampacity of a conductor is the maximum current that it can safely carry without overheating. The NEC specifies the ampacity of different types of conductors based on their size, insulation, and installation conditions. The overcurrent protection device should be sized no larger than the ampacity of the smallest conductor in the circuit. It's also important to consider the load that the circuit will be serving. The load is the amount of current that the electrical equipment connected to the circuit will draw. The overcurrent protection device should be sized to accommodate the load without tripping unnecessarily. It is also important to ensure that overcurrent protection devices are readily accessible. This means that they should be located in a place where they can be easily reached and operated. The NEC specifies maximum mounting heights for overcurrent protection devices to ensure accessibility. Also, ensure that the overcurrent protection device is properly labeled. The label should clearly indicate the circuit that the device protects and its ampacity rating. This information is essential for troubleshooting and maintenance purposes. Consider the potential for future expansion or modifications to the electrical system. If you anticipate adding more equipment or increasing the load on the circuit, it may be necessary to install a larger overcurrent protection device. However, be sure to consult with a qualified electrician to ensure that the existing wiring can handle the increased load. Remember that tamper-resistant receptacles are required in certain locations, such as in dwelling units, to protect children from electrical shock hazards. Tamper-resistant receptacles have internal shutters that prevent the insertion of foreign objects. Also, ensure that all wiring is properly grounded. Grounding provides a low-resistance path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. The NEC specifies the methods and requirements for grounding electrical systems. The NEC also specifies the types of wiring methods that are permitted for different applications. Wiring methods include conduit, cable, and raceway systems. The choice of wiring method depends on the environment, the type of building, and the voltage of the circuit. In addition to overcurrent protection, ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs protect against electrical shock hazards by monitoring the current flowing in a circuit. If a ground fault is detected, the GFCI will trip and interrupt the circuit, preventing a potentially fatal shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are another type of safety device that protects against electrical fires. SIs detect arc faults, which are dangerous electrical conditions that can cause fires. When an arc fault is detected, the SI will trip and interrupt the circuit, preventing a fire. SIs are required in certain locations, such as bedrooms, to provide enhanced protection against electrical fires. The NEC addresses the use of surge protection devices, or SPDs, to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, and other electrical disturbances. SPD divert the surge current away from the equipment, protecting it from damage. SPD are recommended for sensitive electronic equipment such as computers and televisions. Also, ensure that all electrical boxes are properly sized and installed. Electrical boxes provide a safe and secure enclosure for wiring connections. The NEC specifies the minimum size of electrical boxes based on the number of conductors and devices that will be installed in the box. It's also important to properly support electrical boxes to prevent them from falling down. Be aware of the potential for electromagnetic interference, or EMI, from electrical equipment. EMI can interfere with the operation of other electronic devices. The NEC provides guidelines for minimizing EMI from electrical installations. These guidelines include using shielded cables and grounding techniques. In addition to the NEC, other standards and regulations may apply to electrical installations.
These standards may be issued by organizations such as Underwriters Laboratories, or UL, the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE. Compliance with these standards helps to ensure the safety and reliability of electrical installations. When performing electrical work, always use the proper tools and equipment. This includes using insulated tools, safety glasses, and gloves. Never work on live electrical circuits unless you are properly trained and equipped. If you are not comfortable performing electrical work, hire a qualified electrician. It is always better to be safe than sorry. Electrical safety is everyone's responsibility. By following the guidelines and recommendations in the NEC and other standards, you can help to prevent electrical accidents and ensure the safety of yourself and others. Remember to regularly inspect your electrical system for any signs of damage or deterioration. If you notice any problems, such as frayed wires, cracked outlets, or flickering lights, have them repaired immediately by a qualified electrician. By taking these precautions, you can help to keep your electrical system safe and reliable.